what new features come with CoaXPress 2.0 and how you benefit from those. Express and further what new features come with CoaXPress 2.0 and how you benefit from those for your vision applications. So I propose to do that in 4 steps here. I'd like to give you a quick introduction to Euresys, explain the benefits of CoaXPress so that you can really get a base understanding of how it works, expand on those CoaXPress 2.0 features, and then finally a quick summary of available frame grabbers and software technology from Euresys. So who is Euresys? We're entering our 31st year as a company. We're based in Belgium. We have been best known for our frame grabbers and image acquisition technology in the early days, predominantly analog, and then moving together with the industry towards digital image acquisition. And we have a particular specialty in the CoaXPress side. We have 5 offices globally around the world. We have 70 employees, fully half of which are employed in research and development at Euresys. So we're very much a technology leading company. And behind the whole global Euresys team is a worldwide network of distribution and reseller partners. In terms of products, there's 4 main categories that we offer. First and foremost is our frame grabbers, what we're most famous for, most well known for, including CameraLink, CoaXPress, and even ongoing today, traditional analog image acquisition. Through an acquisition of the company Sensor to Image, we now offer the industry's best known set of IP cores that actually implement these vision standards for both camera manufacturers and for frame grabber manufacturers. So we also have a very keen and deep level understanding of how these standards are working. We implement those in FPGA and provide those as products as well to FPGA developers. We also offer a suite of machine vision software known as OpenEVision, and finally some specialty products that aid in distribution of high definition video over standard Ethernet and IP infrastructure known as our video servers. So focus on CoaXPress. We are absolutely convinced of all the standards out there. CoaXPress is the best standard for the machine vision industry, and I really want to help you understand why that is. As Jimmy mentioned, this was first demonstrated in 2008, and first release version 1.0 of the standard was introduced to the market in 2011 via the global standards group known as G3. Through the various industry associations. Most recently, CoaXPress 2.0 was released in June of 2019. I think most importantly to understand or see here is that there are more than 50 companies worldwide providing products in terms of cameras, frame grabbers, and accessories for CoaXPress. So this is not a standard that's limited to 1 or 2 specific companies. It is truly a globally adopted standard, and there's a wide range of availability of products for this, which really speaks a lot to the CoaXPress standard. As Jimmy mentioned, very high data rates are now supported up to 12.5 gigabits per second, which is more than a gigabyte per second over a single coax cable. Just to give you a sense of the evolution of image transport technology coming from GigE Vision, where it was possible to transfer over a simple GigE Ethernet connection at 100 meters, 25 frames per second of a 4 megapixel image. Those standards have evolved over time. USB 3 came to play, then CameraLink, and then you can see the data transport numbers possible with CoaXPress 6 relative to a 4 megapixel camera. These are used in applications that require either very high bandwidth or high frame rate from a single camera, or it's also very well suited to a multi-camera vision system where many cameras are sharing this available bandwidth. Long cable support, as Jimmy mentioned, 100-meter cable support exists. Traditionally at the full speed of CXP12, everything is standardized for 40-meter transfers. What's really important to understand is CoaXPress is a single cable solution. You have very high-speed dedicated bandwidth for image transfer that's uninterruptible. You have asynchronous command and control software between the frame grabber and camera. And also what's really special with CoaXPress is the ability to provide full power to the camera. And some of these high-performance cameras require a lot of power. And that all can be provided over CoaXPress. You also have the feature of low latency deterministic triggering capability. So in real world vision applications, you may be using a web encoder or a part and place sensor as parts are moving down a conveyor line. The ability to detect the part in presence and then immediately trigger the camera to acquire the image is really critical for any vision standard, and this is something that CoaXPress supports very well. Further, there's a heavy dose of standardization of software behind CoaXPress, known as GennyCam, all the way from specifying how a camera, when it's woken up, can immediately communicate with the frame grabber, transmit its XML file, which tells the frame grabber everything it needs to know about the camera that's connected so that the frame grabber can auto-configure itself to work with the camera. Then you have the dedicated video stream and asynchronous channel control back and forth, all standardized for consistent use. Just to illustrate two typical use cases of CoaXPress that really shows the benefit of CoaXPress. You see, for example, here an 8-camera system running with 4K broadcast resolution at 60 frames per second, where you're feeding from a single power source, power to control, to drive all 8 cameras, triggering, synchronizing, and then broadcasting that data out across direct DMA access to GPUs for processing. So this is something you typically see in a type of virtual reality or 3D scene capture application, or also quite common in stadium imaging. And this shows how convenient and easy it is to interface to many cameras in the system, even when it would be 64 cameras, for example, with 8 setups like this. The ability to real-time synchronize the cameras is a really great feature offered here. On the other extreme, you see more and more CoaXPress used in embedded vision applications. So here's an example of a demo that we set up for a customer with one of our low-profile frame grabbers used in an NVIDIA Xavier embedded system via the PCIe slot. We also offer CoaXPress in a PCIe 104 platform for rugged type installations. Simple CoaXPress connection, again, no need to power the camera separately. It's very well suited for embedded applications. And again, also with IP cores to take CoaXPress, implement CoaXPress directly in an FPGA like a Zinc UltraScale Plus. That's a whole system on chip, for example. So now, focusing on CoaXPress 2.0, Jimmy mentioned at a very high level the new features. The first and most important one that he mentioned is CXP10 and CXP12 speeds. Benefits are that you have now doubled the bandwidth to 12 gigabits per second per cable. And that equates to more than 1 gigabyte per second of sustainable data per simple CoaXPress cable. It's fully backwards compatible with CXP6 and even slower speeds of CXP3. There's a new cable connector introduced for CXP12 speed, which is a micro BNC or HD BNC. This provides more reliable positive locking connections. And finally, Jimmy mentioned the point about the confusion sometimes that we hear between CXP 2.0 and CXP 12. It's common that I'm asked if we support CXP 2.0, and what they're really asking is, do we support the 12 gigabit per second speed? So CXP 12 is just one of the new features added within the whole package of CoaXPress 2.0, and it's important to note that all of the new features introduced in CoaXPress 2.0 apply to all previous generations of CoaXPress or previous speeds of CoaXPress. So for example, with CXP6 cameras as well. New feature, universal time stamping. Benefits quickly are to provide a common time reference for cameras, frame grabbers, and software. Previously, these were all running on independent clocks. Now we have the chance to do really precise time stamping of all events for real-time critical applications. An event channel was introduced that allows cameras to send asynchronous messages and status updates to the host. This is working independently with the data stream. And for example, while the camera is doing its image readout and transferring its data at high speed, it can also asynchronously inform the host, meaning the frame grabber, that it's ready to start acquiring the next frame. And those messages are received instantaneously. There's also a new control packet tag. Main goal of this new feature was really to assure robustness for mission critical imaging. It allows the frame grabber to, when it sends a command to the camera, the camera is now required to acknowledge back that, yes, I received your command and I've acted on it. And if that message is not received, it allows the frame grabber to recover from that error and either recommand the camera or re-trigger the acquisition, whatever's required. In the past, this would have resulted in a lost image frame, for example, in a processing stream. Another new feature is data sharing that allows the camera to transmit its image data to multiple hosts. And this is very useful when you have a lot of image data and need to have, for example, multiple different PCs or multiple systems processing either different portions of the same image or doing different functions on the whole image across multiple PCs. Finally, I'd like to wrap up and just give you a really quick overview of products that we offer for CoaXPress. As mentioned, we're one of the 50 suppliers of companies that are providing such products. So we offer a rich set of CoaXPress frame grabbers in various PCI Express bus configurations and input choices, as you can see here. Laid out in terms of the vertical axis showing the different PCI Express bus implementations and bus speeds horizontally at the various bandwidth levels. So we've got a whole range of products that covers you from the low-end, cost-sensitive CoaXPress applications all the way up into the high-end, high performance. We also offer a really unique feature with our DMA engine that allows not just automated restitching of data from multi-tap cameras, but also direct transfer from the frame grabber to a GPU without involving the host CPU. You saw several screenshots of some logic analyzer real-time timing events. That's a tool that's included with all of our Coax Link products known as Memento. And finally, we offer what's known as custom logic, which allows our users the ability to customize the FPGA for programming, for example, proprietary algorithms or something custom specific to an application could be implemented directly in FPGA via VHDL on our frame grabber. There's a quick block diagram of how that appears. And finally, we offer support across a broad range of operating systems and CPU architectures, both ARM and Intel, and operating systems including Windows, full Mac OS support, as well as full Linux support. We offer a tool called eGrabber with a suite of additional tools that fully support all of the GennyCam interfaces, allow third-party applications such as MATLAB that use GenTL standard to gain full transparent access to the frame grabber without needing to write any code. There's an eGrabber Studio. We will soon be introducing Gig E-Link, which will allow 10 Gig E and Gig E Vision cameras the opportunity to use our software and tools from a gigabit Ethernet camera as well as a CoaXPress camera. And finally, we're adding some recording features as well to our tool suite that ships with our products. Last bit of information is Euresys is taking a leading role in bringing CoaXPress to fiber. So I really want to give you a sense of where CoaXPress is going in the future. This now takes a frame grabber, and this will be available to the entire market and will become part of the standard, the next iteration of the standard for full support of fiber, equivalent to single fiber running at the equivalent of 4 CoaXPress 12 links. So even in that case, 4 coax cables can be have the equivalent with fiber optic. So with that, I'd like to hand back to Jimmy